Good afternoon, everyone. This is the subject of power generation process. In this lecture, we are going to discuss about depreciation, and everyone knows that what is power generation, what are the different methods of power generation. I have already discussed or told you about different power plants, that is your thermal power plant, gas power plant, nuclear power plant, and your renewable and non-renewable energy sources and other things. So in this lecture, we will discuss about optimization and appreciation of power plant. So the course objective of this lecture is to introduce students to the basic theory of power generation process and is familiarize with students to the principle of operation of power plant and the depreciation and other things. So learning objective of this lecture I am expecting from students after this lecture that student will be able to understand that what are the depreciation, how it matters for a power plant, and how can we optimize the depreciation. So these are the content of this presentation. One is your introduction, depreciation, minimization. So what is the need of optimize a return and depreciation? So it is often argued that to bring down cost of supply to end consumers, generation tariff should be reduced. Okay, we have already discussed about tariff. So, what is tariff? Tariff is the electricity charges which we pay for our electricity, and there are three type tariff which we have discussed in our previous lecture. That what kind of tariffs we use for consumer. So it is often argued that to bring down cost of supply to end consumers. So what are the methods by which we can reduce the electricity bills, or we can reduce the cost, or we can cut down the cost of electricity? So basic point is that there are few methods we will discuss about them. So cost of supply to end consumers for 2001 to 2 was 350 paisa per unit. Okay. Means 3.5 rupees per minute. It was in 2001 and 2002. Now you can see that day by day it is increasing. Now the electricity cost is your I think 10 rupees per unit. So out of this, cost of generation was only about 150 paisa per unit, whereas about 110 to 120 paisa per unit was on account of ET&C losses. So in the cost of generation, approx 60% is on account of fuel cost. So if you reduce the fuel cost, then you can easily uh, reduce the uh, electricity bill or the cost of electricity. So major part in this tariff is due to your fuel, that is 60%. So need to optimize return and depreciation continue. So a return and depreciation which promote investment in the sector constitute only about 22% of cost of generation. 60% is due to tariff, return and depreciation is your 22%, which is about 9% of the cost of supply to end consumers. So any reduction in return and depreciation, which have only a small impact in reduction in tariff, but will have a multiplier effect on resource mobilizations, since a resource of 1 crore can be leveraged for investment of 3.3 crores. So, return and depreciation need to be optimized considering the requirement of the sector and should not be part of cost reduction exercise. So these are the rate of return options. One is link rate of return with interest rate, return based on investment requirement in the developed economies where there is no requirement for additional investment. Return can be linked to interest rates. In a situation of continuing demand growth in power sector, return has to be comparable with return available in other sectors to attract investment in the sector. So rate of return should be adequate considering the risk association in the sector. Okay. So these are the options which can be used for rate of return. So rate of return, some of the risk is associated with the power sector if you invest some money for the return. So long gestation period, no return on equity during construction period if you are constructing something in power plant, so you will not get any kind of return. So IRR works out to only about 10% for loan repayment period of 10 years. Financial health of SEBs indicate payment safeguards, availability of loans of shorter tenure, regularity uncertainty, fluctuations in demand, transmission constraints, fuel risk, and ensuring sustained availability of plant at higher performance level. So, what is the rate of return? The Honorable Commission had earlier appointed Ms. Crisil as consultant for suggesting rate of return. The consultant then suggested capital assisted pricing model based on risk-free return and premium based on risk precipitation in the industry. So CRISIL had concluded that returns available in the power sector are much lower from that of alternate investment opportunities with comparable risk factors and had proposed a rate of return of 8 to 22% for different utilities. So based on the recommendation of the consultant, Commission in its order dated 21/12/2000 had concluded that as such uh, present ROE of 16% is advisable to be retained for the next tariff period as well. It would, however, be ensured that any revision in future would not result in the ROE falling below 16%. This should uses the feeling of uncertainty on the part of investors. So, considering the present requirement of resources for the growth of the power sector in the country, it would be appropriate to the enhance existing rate of return of 16%. Interest on loan, so we have to pay if you are taking loan and power plant take loan, and it has to pay some interest. So, Commission in its order dated at clause 2.10 had said that it is necessary to stick to the original loans as per approved project cost in the original schedule of repayment. So the contracted interest rate shall be applied on the scheduled outstanding loan amount for the ensuing tariff periods. So any bullet payments or extension of the tenor of the loan shall be exclusively to the account of the utilities concerned. So above provision implies that original loans along with original repayment schedules and original interest rate shall be considered for the purpose of tariff, and any benefit of swapping or bullet payment shall be allowed to the utilities. So this is all about your you know depreciation and interest and return rate of the in power sector. Peak load of the transformer. So here you already calculated the maximum demand of the transformer, and you know, diversity factor is also given. So maximum demand is divided by diversity factor. You can get the maximum demand of transformer 1. So maximum demand on transformer 1 is this, like this. Maximum demand on transformer 2. So maximum demand can be calculated for this transformer 2 by multiplying by demand factor into load 12 into 0.6. So this is your maximum demand, which is divided by your uh, diversity factor. You will get the maximum demand on this transformer. Again, for third transformer, same, you can calculate the maximum demand on transformer 3 by this formula. You will get 7 kilowatt. So the diversity factor among transformer is 1:3. So maximum demand, sorry, 1.3. So maximum demand on feeder. Actually, maximum demand on feeder that can be calculated by this formula. This is the formula by which you can calculate the maximum demand of the feeder, which is equal to individual peak load divided by diversity factor. Okay. So the diversity factor among the transformer is given 1.3. So individual maximum demand you have already calculated, which is your 4.33, 2.057, and plus 7. So you will get 10.3 kilowatt is the maximum demand, which is through feeder. Okay. So this is our numerical number 2. Now we come to the next problem. A substation is having the following loads. So the load is divided into three parts. It may be your domestic, it is your commercial, and your industrial load. So maximum demand for domestic load is 1500 kilowatt, and diversity of the group is 1.2, and demand factor is your 0.8. For commercial load, the substation has maximum demand is 2000 kilowatt, and diversity of group is 1.1, and demand factor is your 0.9. For industry, the maximum demand is 10,000, diversity of group is your 1.25, and demand factor is 1. So if the overall, actually in this question, maximum demand is given, connected load is not given. Diversity of the group is also given, and demand factor is also given. And the overall diversity factor is also given for the transformer, that is your 1.35. So first you have to calculate the maximum demand and connected load of each type. Okay. So from this diversity, the diversity factor is equal to individual maximum demand upon maximum demand of the transformer or the feeder. So the sum of maximum demand of three type of load is 1500 plus 2000 plus 10,000. It is your 13,500 kilowatt. And the system diversity factor is already given, which is 1.35. So you can easily calculate the maximum demand of the supply, which is equal to the sum of individual maximum demand divided by the system diversity factor. So you can calculate the maximum demand on supply system, which is equal to 10,000 kilowatt, right? So it is very easy to calculate. Now you have calculated the first part of this question. Now we come to the second part, in which you have to calculate the connected load of each type. So demand factor is also given. So what is the formula of your demand factor? Is equal to maximum load upon connected load. Okay. So by this formula, you can easily calculate the connected load. So each type of load has its own diversity factor among its consumer of maximum demand of different domestic consumer. So maximum domestic demand into diversity factor is equal to 1800 kilowatt. So for connected domestic load, the maximum demand, see, the maximum demand for this connected load is your 1500 kilowatt, and the formula for demand factor is equal to peak load upon connected load. So peak load can be calculated by your maximum demand into diversity factor. So this is your peak load for domestic purpose. So peak load is divided by your demand factor. You will get the connected domestic load like this. Peak load for this is your 2000. So this is your 2000 is multiplied by 1.1. You will get the connected load for this commercial load, and the connected industrial load is your, this is your peak load. So peak load can be uh, uh, calculated by maximum demand into your diversity factor, which is divided by your demand factor. So you can easily calculate the uh, connected load of these three type of loads. Okay, so these are some formulas by which you can easily calculate your maximum demand, peak load, diversity factor, and demand factor. Now next come to the next question. The next numerical is that a substation has a maximum demand of 1,50,000 kilowatt. Okay, so the maximum demand of substation is given, that is your 1,50,000 kilowatt, and the annual load factor is given. Okay, so the annual load factor is 50%, and plant capacity factor is 40%. So determine the reserve capacity of the plant. Okay, so everyone knows in the last lecture, I already told you that the reserve capacity is equal to plant capacity minus maximum demand. Okay, so for calculating the reserve capacity, you required plant capacity, and maximum demand is already given. So first you have to calculate the plant capacity. So the formula for plant capacity is equal to unit generated per annum divided by plant capacity into hours in a year. Okay, so the energy, first we have to calculate it, the energy generated per year. So maximum demand is given, which is your 15,000. Load factor, the formula for load factor is your average load upon maximum demand. Okay, so the energy generated per year can be calculated by this formula, which is equal to maximum demand into load factor into hours in a year. For a year, the number of hours is your 8760, and 15,000 is your maximum demand. Load factor is given your 50%, which is less than 1. So the energy generated per year is equal to 65 into 10 to the power 6 kilowatt hour. Now you have to calculate the plant capacity, so which is equal to unit generated per annum which is your 65 into 7 10 to the power 6, and the maximum demand, or you can say the plant capacity factor into hours in a day. Okay, so the plant capacity can be calculated by by cross multiplication. So plant capacity is equal to unit generated per annum upon plant capacity factor into hours in a year. So plant capacity will be 65 into 7 10 to the power 6 divided by 0.4 into 8760, which is equal to 18,750 kilowatt. Okay, so this is your plant capacity. Now next we have to calculate your reserve capacity. So you know the plant capacity and you know the maximum demand. So plant capacity minus maximum demand, you will get the reserve capacity of this plant. Okay, so the reserve capacity will be 3,750 kilo. Now next come to the next question, that a substation supplies the following loads to various consumers. Okay, in which we have four loads. One is your industrial consumer, it is supplying 1500 kilowatt. Commercial establishment, it is supplying 750 kilowatt. For domestic purpose, it is supplying 100 kilowatt, and for domestic light purpose, it is supplying 450 kilowatt. So the maximum, if the maximum demand on the station is 2500 kilowatt, actually the actual maximum demand of this substation, it is not for particular load. This is the maximum demand of substation, which is your 2500 kilowatt, and the number of kilowatt hour generated per year is 45 into 10 to the power 5, and the number of kilowatt hour means the energy generation or of per year is given 45 into 10 to the power 5 kilowatt hour. So first you have to determine the diversity factor and then annual load factor. So you know the formula for diversity factor, that is your individual demand divided by your maximum demand. So individual demand is your 1500 plus 750 plus 100 plus 450 kilowatt for different load, and it is divided by this maximum demand of the substation. Then you can easily calculate the diversity factor of the system, which is 1.12. Now average demand. So the average demand of the actually load factor of the uh, substation is average load divided by maximum demand. So maximum demand but calculate the average load, you have to use this formula, which is your energy generation per year divided by hours in a year. So energy generated per year is your 45 into 10 to the power 5 kilowatt hour, which is divided by your hours in a year. So you will get 513.7 kilowatt. This is your power demand or average demand of yearly. So average load is your 513.7, and the maximum demand is your 2500. So the load factor is your 0.205, which is 20.5%. So by these formulas, you can easily calculate the, uh, you can easily solve the numerical problem which is given. So once you can check that demand factor is always equal to peak demand upon connected load, peak load can be calculated by this formula, and diversity factor is equal to individual peak load divided by peak load of the transformer. Let's come to the next question, that a generating station has a maximum demand of 25 megawatt and a load factor of 60%. So the maximum demand of the generating station is given, which is your 25 kilowatt, and the load factor is given 60% of a plant capacity factor of 50%. Plant capacity factor is given, load factor is given, and a plant use factor is given, which is your 72%. Now you have to find out the reserve capacity of the plant. So the reserve calculation of the reserve capacity of the plant, you need plant capacity minus maximum demand. So maximum demand is given, but you have to calculate the plant capacity, and the formula for plant capacity factor is equal to average load or average demand upon plant capacity, and plant capacity factor is given, which is your 50%. So you have to calculate the average demand, and average demand you can calculate by the load factor. So load factor is your 60%. Okay. So load factor is your 60%, and you know the formula for load factor is equal to average demand upon maximum demand. So by using this formula, you can easily calculate the load factor. So this is 0.60 is equal to average demand upon 25, and average demand is equal to 25 into 0.60, which is equal to 15 megawatt. Okay. So plant capacity factor is equal to average demand upon plant capacity, and plant capacity can be calculated by average demand upon plant capacity factor. Average demand is your 15 megawatt, and the plant capacity factor is given your 50%, which is 0.5. So the plant capacity is your 30 megawatt, maximum demand is your 25 megawatt, and the average demand is your 15 megawatt for this station. Now the second point is you have to calculate the daily energy produced. So how much unit the this generating station is producing every day. Okay, so you can calculate the daily, sorry, so first you can calculate the reserve capacity of plant, which is equal to plant capacity minus maximum demand. So this is your 5 megawatt reserve capacity of this plant. Now the second point is you have to calculate the daily energy production. So from this, uh, you know, average demand is your 15 megawatt. If you multiply by this hour or time, you will get the energy which is producing daily basis. So you can multiply this 15 into 24, 24 hours per day. So you will get 360 megawatt hour. That much energy is producing by this power plant and on the daily basis. Now maximum energy that could be produced. So maximum demand, that maximum energy, you have to calculate the energy. So actual energy divided by plant use factor, you can get the maximum energy or plant capacity of this uh, substation. So it can generate 500 megawatt hour per day, but it is generating only 360 megawatt hour daily on daily basis. So this is about your maximum energy and daily energy production. Now let's come to the next question. So next question is that a substation has to meet the following demand. Okay, there are four groups, and the group A required 200 kilowatt between 8 a.m. to 6 p.m. Group B required 100 kilowatt between 6 a.m. and 10 a.m. Group C required 50 kilowatt between 6 a.m. and 10 a.m. and Group D required 100 kilowatt between 10 a.m. and 6 p.m. So these are the demand of a particular group, that for this particular time they require this much of power, for this particular time they require this much of power. Group C, for this particular time this required this much of. So now you have to plot the daily load curve. I have already discussed in the last lectures that daily load curve is plotted between the time and the load. And from the curve, you have to determine diversity factor and units generated per day and load factor. So first, what you have to do, first you have to make a table for individual group. So from this table, you can see that from uh, midnight to 6 a.m. only 6 p.m. Sorry, 6 p.m. to 6 a.m. Okay, only 100 kilowatt load is required. Like from evening 6 to morning 6, only 100 kilowatt load is required. Then morning 6 to 8, you can check that group B, morning 6 to 8, 100 kilowatt load is required, and 6 a.m. to 10 a.m., 50 kilowatt is required. After that, 8 to 10, 8 to 10, 8 to 10, you required 100 kilowatt, 8 to 10 you required 50 kilowatt, and 10 a.m. to 6 p.m. and 6 p.m. to, sorry, 10 a.m. to 6 p.m. No, 8 a.m. and 6 p.m. you require 200 kilowatt. Okay. Now 10 to 18, 10 a.m. to evening 6 p.m. you require 200 kilowatt, 100 kilowatt. Okay. So these are only morning load which is required from 6 a.m. to 10 a.m. means 6 to 8 and 8 to 10. Okay. So you can see that 6 to 8 and 10 to n you required group B and group C required power, but group A required power from 8 to evening 6 p.m. So you can see that it is required for these two columns. But group D required the power from 10 a.m. to 6 p.m., 10 a.m. to 6 p.m., and after 6 p.m. to 10 a.m. to 6 p.m., and then between 6 p.m. to 6 a.m. Okay. So the total load on the power station is 0 to 6, 600 kilowatt, 6 to 8, it is 150 kilowatt, 8 to 10 is your 350 kilowatt, and 10 to 18, it is 300 kilowatt, and 18 to 24, it is your 100 kilowatt. Now you can easily draw the graph, plot the graph. So from this table, it is clear that the total load on power station is 100 kilowatt from 0 to 6 hours. For 0 to 6 hours, you required only 100 kilowatt. Next, for 6 to 8 hours, 6 to 8 hours, you required 150, sorry, 0 to 6 hours, it is required 6 to 8 means from 6 a.m. to 10 a.m. you required 150 kilowatt. 6 a.m. to 10 a.m. you required 150 kilowatt. So you can easily plot that is your 150 kilowatt load. After that, from 8 to 10, 8 a.m. to 10 a.m. you required 350 kilowatt. So 8 a.m. to 10 a.m. you required 350 kilowatt. Then 10 a.m. to in the evening 6 p.m. you require 300 kilowatt. So this is your right. 10 a.m. to evening 6 p.m. you require 300, and after that 6 p.m. to again your 6 p.m. to again 6 a.m. you required 100 kilowatt. So this is your 100 kilowatt. Okay. So for 18 to 20 hours, it is required 100 kilowatt. Now, plotting the load on power station versus time. So we can get the daily load curve as shown in the figure, and it is clear from the curve that maximum demand on the station is 350 kilowatt. Okay. So maximum demand is your 350 kilowatt, and sum of individual maximum demand of the group, which is sum of the individual maximum demand of the group is given 200 plus 100 plus 50 plus 100, which is equal to 450 kilowatt. So diversity factor is equal to maximum individual maximum demand 450 divided by maximum demand of a station, which is 1.286, and the units which is generated per day, which can be calculated by the area under of this curve. So the unit generated per day area in kilowatt hour under the load curve. So you can easily calculate the area of this is 0 to 6, 100 into 6. Then for next 2 hours, this is 150, 150 into 2. For next 2 hours, this is your 350. Then next 8 hours, this is your 300. Then next 6 hours, it is your 100. So you will get the unit generated per day is equal to 4600 kilowatt hour. Now you can easily calculate the average load, which is equal to unit generated per day divided by time. So it will be 190.7 kilowatt, and load factor formula is average load upon maximum demand. So average load is given 191.7 kilowatt, which is divided by your maximum demand. So it becomes 191.7 divided by 350 into 100, which is equal to 54.8%. So this is all about your this numerical. Now we come to the next numerical, which is in which the daily demand of three consumers are given. Consumer number 1, consumer 2, and consumer 3. And the time of this uh, load is 12. It is starting from 12 midnight to 8 a.m. So you can calculate the hours from 12 midnight to 8 a.m. Consumer 1 don't require any kind of load. Consumer 2 require 200 watt, and consumer 3 is not consuming any load. From 8 a.m. to 2 p.m. From 8 a.m. to 2 p.m. you required consumer 1 required load, which is 600 watt. Consumer 2 don't require any kind of load, and consumer 3 is also required 200 watt. Like this, from 2 p.m. to 4 p.m. it is required 200 watt. Consumer 2 also required 1000 watt, and consumer 3 required 1200 watt. And from 4 p.m. to 10 p.m. consumer 1 required 800 watt, consumer 2 required no load, and consumer 3 also required no load. From 10 p.m. to midnight, the consumer 1 required no load, and consumer 2 required 200 watt, and consumer 3 required 200. So now the question is that first you have to plot the load curve, then you have to find out the maximum demand of individual consumer, and the load factor of individual consumer, diversity factor, and load factor of the station. Okay, so first we have to plot the load curve. So by simplifying this table, we can plot the load curve. So you can see that from 12 midnight to 8 a.m. Okay, so this is your how much hours? It is your 9 hours. Okay, from 12 midnight to 8 a.m. you required 200 watt load. So 12 midnight to 8 a.m. you are getting 200 watt. From 8 a.m. to 2 p.m. you require 800 watt. You can check like 600 plus 200. This is your 800. Now 2 p.m. to 4 p.m. you require 2400. 2 p.m. to 4 p.m. you require 2400 watt. Then for 4 p.m. 4 p.m. to 10 p.m. you required 800 watt. 4 p.m. to 10 p.m. you required 800 watt. From 10 p.m. to 12 midnight you require 400 watt. So this on y-axis we are taking load in watts, and on x-axis we are taking time in hours. Okay. So maximum demand of consumer 1, you can see that is your 800 watt. Okay, this is your 800 watt. For consumer 2 it is your 1000 watt, and for consumer 3 it is your 1200 watt. Okay, now load factor of consumer 1. So load factor formula is average load divided by maximum demand. Okay, or peak load. So energy consumed in a day. So first you have to calculate of maximum demand of individual consumer. You have already calculated. Now you have to calculate load factor of individual consumer. So load factor of individual consumer you can calculate by this formula. So 600 is consumer one is consuming for 6 hours. 600 is consuming for 6 hours, and 200 is for 2 hours, and 800 for your again 6 hours. So energy consumed by this consumer is 600 into 6, 200 into 2, plus 800 into 6, and it is divided by maximum demand into hours in a day, so which is your 24 hours. If you want to calculate it in a percentage form, you can calculate it easily. It will become 45 into 0.8% for load factor of consumer 1. Like this you can calculate. Actually this is the formula of average load. Okay, average load is divided by your peak load. So average load, you can calculate the average load by this formula. So you are calculating average load, which is divided by maximum demand. Okay. So easily you can calculate the load factor of for consumer 1, consumer 2, and consumer 3. So which is your for consumer 1, which is your 45.8%. For consumer 2, it is 16.7%. For consumer 3, it is 13.8%. Now we come to the next point, diversity factor. So diversity factor can be calculated. I have already told the formula, that is your individual maximum demand upon maximum demand of the station. So the maximum demand of the station is, you can check, is 2400 watt. Okay, and individual maximum demand is already given 800,000 plus 1200. So you can easily calculate the diversity factor of this station, which is 1.25. So sum of individual maximum demand is this, and the maximum demand by your substation is your 2400, which is equal to 1.25. Now, station load factor, which is equal to total energy consumed per day divided by simultaneous maximum demand into 24. So, station load factor can be calculated by this formula. So, total energy consumption is your, you can calculate it by this diagram, and you will get the total energy consumption of each consumer and divided by simultaneous maximum demand, which is your 2400. And if you want to calculate it in percentage, you will get 29.1%. So station load factor is your 29.1%, and these are your individual load factors. So now I think it is clear to you that how can you calculate your diversity factor, maximum demand, load factor, average load, energy, how much energy you are generating through the power station, and how can you plot how should we can plot the load curve, uh, and the calculation from the load curve. Now we come to the some some MCQs which is based on this lecture. So these are some MCQs. So a load curve is plot of load versus time. For economy in generation power, the diversity factor should be high, plant utilization factor should be high, load factor should be high, load factor and diversity factor should be low. For economical power generation, your plant utilization factor must be high, because if your plant is having the capacity of 500 kilowatt and you are generating only 200 kilowatt, then the plant capacity is not fully utilized. So for economy in generation power, the plant utilization factor must be high. Now, which of the following category of consumer can provided highest load power factor? So the continuous process plant is always provide highest load factor. If your load factor is high, then the cost of electricity generation will be less. Now the next question is, the load of a consumer is generally measured in terms of kilowatt. The normal connected load of a domestic consumer is usually up to 10 kilowatt, 10 to 20 kilowatt, 25 to 50 kilowatt, 50 to 100 kilowatt. So the normally connected load of domestic purpose is only up to 10 kilowatt. Now, load factor during a period. So the formula for load factor during a period is equal to average load divided by maximum load. Then you will get the load factor. Which of the following installation provides peaked load? So arc furnaces is always provide the peak load. Next is your demand factor is the maximum demand upon connected load. This is the formula of your demand factor. So these are the references of these numericals. You can go through these numericals and you can easily analysis of a substation, and by analysis of a substation you can easily calculate that how much load is required for a particular consumer, how much maximum demand is required for a particular consumer, and what is the diversity factor, what is the efficiency of the plant, what is your load factor. So by these different numericals, I think you are it is clear to you that how we can plot the load factor, load curve, and under the area of load curve is always gives you the unit which is generated by that particular power plant or substation. And uh, by using load curve you can easily calculate the diversity factor, maximum demand, and your utilization factor and your load factor. In next lecture we will solve some more numericals, so it will make you clear, and it will remove your all confusion and the doubts for mathematically analysis of these load curve or economic of power generation. Thank you.